A problem like number 2 is where we're trying to calculate the heat of solution. So we're putting a chemical in water and checking the temperature change there. So delta H is expressed in different units than Q, but we are going to use Q because Q does equal delta H at constant pressure. And if we're just staying in the same room and not pressurizing the room or anything like that, Q is delta H. But again, that's only at constant pressure. Q is usually in joules or kilojoules, but delta H is often in those kilojoules per mole. So this is how you work a problem like this. We're going to just focus on the kilojoules part first, and the way we get that is Q equals MC delta T. Now, you have several masses in here. You have the 16.9 grams of NaOH and the 70 grams of water, which is also 70 milliliters because the density of water is 1. Now, the best advice I can give you on how to apply this to other things or other situations is you want to use the mass of the thing that is changing temperature. In this particular problem, we are checking the temperature change of the water. So that is the mass I want to use. And if they'd had 70 milliliters, I could just change that to grams, again because of density. And water's specific heat is 4.184 joules per gram degrees C. And my temperature change for the water is from 88.6 degrees C to 22.4 degrees C. Final minus initial, that's going to give me 64.2 degrees C. So, as I multiply these together, grams and degrees C cancel out. My answer will come out in joules. And with 3 sig figs, I get 18800 joules of heat. Anytime you get joules over 1,000, it's a good idea to convert it to kilojoules. So 1, 2, 3, that is 18.8 kilojoules of heat. Now we want to work on the mole part. This is where you're going to use that 16.9 grams of sodium hydroxide. It's per mole of what you're adding that made it change temperature. And that's the best way to look at per mole in these delta H calculations. So we're going to take 16.9 grams of NaOH, and I'm just going to convert this to moles because water didn't just heat up on its own. I added this chemical and that caused it to heat up. So the molar mass of NaOH is right around 40 grams in 1 mole, and that's going to give me 0.423 moles. Excuse me. So now I need to get my kilojoules per mole. So I take my kilojoules and I divide it by my moles. And when I divide, I get 44.4 kilojoules per mole. Now, I have to assign a sign, and this is just something that you just have to know which way it goes. Is this reaction endothermic or exothermic? Well, the temperature went up. That means heat will be given off, and when heat is given off, you assign it a negative value, and that is your answer.